Hello, everyone. I see that there is a highlight that's not supposed to be there. We'll forget about it. OK. Hello. My name is John, and I'm a frameworkaholic. And I'm currently in rehab right now. Now, jokes aside, I know what you're thinking. This is a guy yelling at a framework saying, OK, you have to get rid of everything. But that's not the case, of course. First, I'm John. I work for Chillit. We like to experiment with new things. And I've been experimenting with something, and I want to share that with you, share my experiment. Let's see what comes out of it. I really like to have a discussion with you on what you think about it, what your opinions are, what your experiences are. So let's do it. So first, let's address the elephant in the room. Am I claiming to say, OK, you should get rid of your framework altogether? I think you know the answer to that. Of course not. Frameworks are great. They help your productivity. They help you get started quickly and also help your projects move along. But as a consultant, I see different projects, and I see a lot of mistakes, or what I call a mistake, happening that hurt us in the long run as developers, and I think we should get rid of that. And I'm going to use solid principles, of course, to make sure that we're doing the right things. So let's start. First, I, of course, have to convince you that you might want this or not. And I'm going to start with that as a developer, you are an architect. I think you might think, OK, I'm not an architect. My title doesn't say software architect. But we are. When we name a class, when we put something in a certain package, if we design a package structure, if we're saying, OK, I'm going to put a new application here in this landscape, you are doing software architecture. And as an architect, you have a job. And I think the most important job that you have as an architect is to keep options open. The soft in software stands, of course, for flexible. You want it to be easy to change. And if you are tying everything to your framework, you are closing down an option to maybe change something about that framework. Maybe let's illustrate that with a quick question. Who of you is using Spring Boot? That's a lot. OK. I was expecting that, yeah. And who's still on Spring Boot 2? Nobody is on Spring Boot 2? One person. OK. Two persons. OK. That's good, because it's, of course, end of life for a while. But who has been on Spring Boot after it was end of life? It was in 2023? Also not. OK. And, quick migrators here. But as an architect, you have a job to maximize decisions not made. When you are tying everything to a certain database, a certain framework, you are closing down options, because it's not impossible to switch, of course, but it takes a lot of work and it takes a lot of time. And when you tie everything into your framework also becomes an actor in your system, because they demand breaking changes. When you migrated from Spring Boot 2 to Spring Boot 3, there were breaking changes in there, and you had to migrate your existing code. So when you have tied your core domain and your core business logic into your framework, you also have stakeholders, of course, and stakeholders also want change, because if you have worked with a stakeholder any length of time, at least in my personal experience, they change their mind a lot. So they want change in the business logic as well. So now you have two reasons for change for the same piece of code. And that violates the single responsibility principle. which states that code should be responsible to only a single actor. And I'll start with a story where I made this mistake, or at least I made this mistake actually multiple times. I'm sometimes making this mistake again in my daily work. But I was working for a large company in the Netherlands, and this was in a time when it was very fashionable to include the whole Netflix stack in your programs, in your applications. And we were also overly excited about microservice architecture. So of course, microservices everywhere and no regard for any consequences of that. So we implemented, of course, a thin client, and we also thought, okay, we want to avoid cascading failures, so let's implement hystrix for circuit breakers. And I think circuit breakers are still great, they're a good idea, but not in the way that I did it, or me and my team did it. That was something like this. We had a service, and there was some business logic in there, but I only have so much room on the slide, so I won't bore you with any actual business logic. But we had a thin client in there, we called an external service, and then we got back the data, and then we did something with it. And then we thought, okay, yeah, but this call can fail, of course. I mean, the service might be down, we might make a bug where we return an invalid response or whatever. So we said, okay, let's fix that. I'm going to put a circuit breaker in there. So now we're not congesting the network with unnecessary calls, and we might even return a fallback response if that's possible. So we fail gracefully, as we say. And I think this was a mistake. I mean, in this specific example, it might not be because this does nothing but call the service. But usually you have more business logic in there. So imagine that there's also some business logic in there, and then this happens. And we also might want to change from a stakeholder. So now we have multiple reasons for change, because hystrix was going into maintenance mode, and there was an announcement that it might be removed will be removed in the future, and that also happened. So now we had to change for multiple reasons. So let's see how that looks like in an example application, how you normally would do it. I'm not going to bother you with a very complex architecture. I'm not going to do like hexagonal architecture. It doesn't really matter what type of architecture you're using. The principles still apply, and I think that, for example, hexagonal architecture also addresses this problem. So what we have here is just a simple three-layer. You might see this in a lot of projects. You have a controller. Let's imagine that there's a REST controller in there, but that's not really important in this example. It's just there. It calls some business logic, so it's dependent on it. That's why the arrow is pointing to it. It has an import, basically, of that class, and so it calls it. And then it also has, the service has a dependency on database entities, and also, in this example, a JPA repository. But it can also be JDBC, can be anything you want. But now we're forgetting a very important dependency arrow. Because usually, when I annotate it with @service or @repository, I also have this arrow. And maybe for the JPA repository, it's not that bad. For the controller, it's also not that bad. But for the service, it is bad, because it's pointing to the framework in two different ways, even. It's pointing directly, but it's also going through JPA, which is basically an I/O interface. And it also goes through framework through that. And I think that's bad. So let's see how that looks in code. You have the service. It imports the service annotation from Spring Boot for Spring. And it points to the JPA repository. That looks something like this. Also imports, of course, Spring Framework. So I think that's not the way to go. But what is the way to go? How do we decouple it? Well, we're going to separate the core logic and the core domain from the framework. And we can use the D from the solid principles, or dependency inversion principle, to break free, basically. We're going to invert the dependency. So we're not going to let the arrow point at the framework. We're going to point the framework at our core logic and core domain. And now I've used the term core domain a few times, so I want to make an explanation of that, basically. Because I see this also going wrong in a lot of projects. So what is your core domain? Let's first start with what is not. It's not your database tables. Your database tables is not your core domain. Your database tables are the result. They are on an I/O device. They are on a disk somewhere. And I/O is not your core. So now that we know what it's not, what is it? To me, it's a model of reality of your business. So if you're in banking, for example, it might be a bank account. It might be an account holder. If you're working in transport, in trains, for example, it might be a train cart or someone going on the train to check your tickets. This is what it is, and it's abstract. And also subject to change. Because when you're first starting a project, you might not know what the domain looks like. Usually, you're not a domain expert. You're a software expert. So you're going to make mistakes, and you're going to want to change it. And if your core domain is your database tables, it might be a little bit hard to change because you have to maybe write database migrations, or, God forbid, you have to change it manually. Then you might opt for being stuck, not change the domain because it's hard to change. And I've seen this in a project as well, where we basically use two terms for the same thing inside our projects, because, yeah, the database table is already called that, so, yeah, it's hard, so let's keep it. So I want to separate that out as well. So, of course, that also results in more code. That's the unfortunate reality, but I think it's good in the long run because it's flexible. So this is basically what I made out of it. And this is not like you have to do this. This is just an example. It's a simple example. You can apply any type of architecture to it that you want. It's just the principles that I want to talk about. So as you can see, the domain is on the bottom, and everything is pointing to it. That's basically where we're going to start from. So it's actually pretty simple. As you can see in red where we are, we have an entity, and that is a business entity. So this is not a database table. This doesn't have any annotations from JPA or JDBC or whatever. It will just be a plain Java class, Java record, whatever you want. And it's an entity, so it's tracked by its ID. So it has a unique ID. You might also have some sub-entities that might be tracked by their parent, then might not have an ID if it's only tracked by its parent. But in this case, this is basically an aggregate, so an aggregate root, I should say. So it's tracked by its ID. And it only has imports that start with Java, because we have to start from somewhere, and that's where we're going to start from. Then we have a data access interface. And the data access interface, well, the name says it already. It's an interface. And it's a plain Java interface. It's not going to import anything from a specific storage interface or whatever. So it's not going to import JPA, for example. But it will, of course, import our entity. And it also returns our entity if you search for it, by its ID, for example, in this case. Then we have our business logic. And I just created a similar service for it. So this might do some logic on a domain entity or whatever you can think of. And so it imports this entity in this case, and it imports the data access interface. So you can see the dependency arrows in red pointing to it. Then in this case, we have, of course, the JPA repository still. And the only change here is that it extends the JPA repository. Actually, it's quite the same as before. And then we have our database table. So this is usually what I see in most projects as the core domain. But I separated it out here. It might be the same as the domain. It might be different. That depends on your project, and it depends on the context that you're working in. Then we have our data access object. And our data access object is basically what is binding everything together regarding data access, data storage. So it's depending on the data access interface because it implements it. So the data access interface dictates what the data access object should do, should implement. And in this case, it's pointing to my JPA repository. In this case, it is the JPA data access object. But if I want to change it to say, OK, it's an in-memory data access object, and I just have in-memory data structures, then I can just do it. And it's very easy to do, because I just implement the interface, and maybe I put a hash map in there, or whatever. Then I have, of course, a product that points it all together, and this is where the dependency inversion comes in. So what we have here is now, so this is basically in our outer layer. So I would also, when I would make this exact project, I would also make different modules out of it. So I would put the domain classes and the data access interfaces together in the same module. I would separate out the business logic, and that would be its own module. And I would put all the I/O stuff. So that's the controller, that's the framework configuration, and the repositories and the database entities I would put in the same module. And you could also split that out based on how you want. And of course, you can also split this configuration. In this case, I only have 2 classes that I have to instantiate, so it would make no sense to make multiple configuration classes. But for example, I might have a configuration class where I put all my JPA stuff, and I maybe put a profile on it, so I switch on profile, and I would also have maybe an in-memory version, and then I would put that in a different configuration, and I would put maybe profile in-memory on it. And now I can switch my Spring profile, and now I have a full in-memory application by just switching it. So let's conclude. In my opinion, frameworks are great, but don't let them dictate your architecture. So let the framework point to your business logic and your core domain instead of the other way around. So they should be independent. These are the most important things you're working on. Business logic and the domain are the most important things that you're doing. And you can defer maybe even a framework decision while you're making your business logic. Or you can defer what type of database you want to use, because maybe you start just in memory with some hash maps. can do it. And then you can just add the database stuff later. And use the dependency inversion principle to separate those concerns. So I want to thank you all for listening to my talk. Of course, we at Chillit we have a stand, and we have some waffles that you can go and take, or play some fun games with us. Our hot sauce challenge is back, but we are doing a gaming twist on it. So if you've checked it out before, please check it out again. If you've never been there, check it out as well, of course. In the goodie bag that you've gotten, there's a booklet in there, and that also explains what we have. We also have some prizes to win, so please check us out. So thank you all for listening, and have fun at JSpring today.